Alright guys, hi. As you can see, I am not there right now. I'm at a funeral now for one of my friends. I'm not there. Um, but you guys still have some work to do. You were just continuing about experimental probability, which was what you did last class with the coin flip. Remember when you flip the coin 40 times with you and a buddy? Same thing, okay? Only this time, instead of just like figuring out the normal theoretical probability, where like if it's how many times do you roll a 2 on a dice, this time they're going to tell you all of the numbers and you have to figure out the percent for each time. So if you don't already have a calculator and this paper, go get it because you're going to need it. Just saying. Okay. Pause, go get that. All right, we're back. Okay, so to find probability, this part has not changed no matter what probability you do. You always take the number of outcomes divided by the total number times 100, and that is how you get the percent. Okay, if it's not asking you for the percent, don't multiply by 100. Okay, if it's just asking you for like the probability, you can just write it as the fraction. It's totally okay. So number 1, if you roll a number cube and land on a 6, okay, landing on a 6, it means you win a prize at the local Hispanic festival. Cecilia is tracking the number of players who roll a 6, and she wants to know what percentage of players won a prize. So that right there, we're introducing one more vocab term. Okay, relative frequency. Whenever you see this term relative frequency, they are asking you to find the percent. Okay, that's what you're going to find. You're going to find the percent for each day. Okay, so remember what I told you, you take the number of outcomes divided by the total number. So in this case, we're trying to figure out how many people were winners. Okay, how many people won. So for Saturday, how many people won? 22. We're going to take 22 out of how many people played on Saturday, which is the 125. Okay, so again, we are going to divide that. So in our calculators, we need 22. Where's my calculator? Oh, there it is. Okay. I'd open it in a different screen. So you need to do 22 divided by the 125. Okay, that's just your decimal. Okay, remember that's not the percent yet. For the percent, you have to take that one extra step, multiply it by 100. There you go. That's your percent. So it's 17.6%. Okay, so that's what it is for Sunday. Okay, now you have to do the exact same thing all over again for Sunday and for the total. So do it. Okay, so for Sunday, again, there were 28 winners. So we're going to put 8 out of the 138 that played on Sunday. Again, in your calculators, okay, we need 28 divided by 138. Okay, should get that lovely decimal. Okay, but again, that's not our percent. For the percent, you have to take that one extra step and times it by 100. Times 100. Boom, there you go. Okay, now you can round it to the nearest tenth, which hopefully when you do your Prodigy homework, you'll see that for timesing by for rounding, okay, to the tenths place. Tenths place is 1 decimal, so that's this 2 right here. Okay, so you need to take this 2, look at the number right after the 2. It's that 8 right there, right? So will an 8 make a 2 round up or stay? Hopefully you said round up. Okay, so this is going to turn into 20.3%. Appreciate God. Okay, now we have to do the last one. We have to do the total. So for the total, 50 people won this time out of the 263 people that played, and that's for like the entire weekend. So out of the whole weekend, only 50 people won out of 263 people. So that percentage, 50 divided by 263, we get that again. Still to multiply by 100. So there's your percent. So our percent is 19 point. Again, we have to round. So the tens place is that first decimal. So look at the number right after it. That 1 right there. Will a 1 make a 0 go up or stay? Hopefully you said stay. Okay. Remember, to round, the number has to be a 5 or higher to make it go up. If it's a 4 or lower, it stays. So you can just put 19, or you can put 19.0. It's up to you. There. I'm going to put 19.0 just because I already wrote the decimal and I'm erasing it. So I'm going to put that. There you go. All right, so there are all of our percentages of players that won a prize. Now, number 2 is asking if Cecilia had 47 winners out of 275 players, what was that experimental probability? So again, to find probability, you should number of outcomes divided by the total times 100 to get the percent. Hey, look, that's a percent sign. So we have to do all that fun stuff. So let's try it. So figure out how many people were the winners. So there are 47. So we want 47 out of how many people played total? Total was 275. So again, in that calculator, I need 47 divided by 275, okay, equals that lovely. But remember, you have to do the times 100 to get your percentage. There you go. All right, and again, we're rounding to the tenths place. So that is 1 decimal. So that's that first thing, the first number right after the point. So look at the number right after that. It's a 9. So think about it. Will the 9 make a 0 go up or stay? Hopefully you said go up. So it's going to turn into 17.1%. Okay. So 17.1%. So just like think about it, like, and this isn't on your paper, but I want you to think about it because we're smart noodles. We can figure this out, right? What day would have been the best day for you to go and play? Hopefully you said Sunday. Sunday had a higher percentage. Now, this is during 2 different weekends. Which weekend would you have had the higher probability of winning if you'd gone that week? Was it weekend number 1 or weekend number 2? Hopefully you said weekend number 1. Okay, it was weekend number 1. Because when you look at the total percentages, we had 19%. Okay, 19% wins over 17%. It's higher. Okay, so we would have had a better chance winning on the first weekend than the second weekend. So hopefully that makes a little bit of sense. So again, all of these are percentages based off of something that happened. Okay, like the experiment that you did where you're flipping the coin. These are the percentages of like people that actually played the games and won. Okay, this isn't just our theory or our prediction of how many people we think are gonna win. This is actually how many people won. That's what makes it an experimental probability. Okay, so let's try it. We got one more. So it says Joanne kept track of players and winners for her game at the same festival. Based on the results shown in the table, how many winners would she expect if 300 people played her game? All right, so again, we have to figure out these numbers right here. And again, whenever you see that phrase relative frequency, they're asking you to find the percent. So that's what we're going to find. We're going to do 3 times here. Okay. So first we're going to do it for Saturday. So go ahead, write the winners out of the total for your fraction. Sorry, this towel was getting parched. Okay, so again, I want my winners out of the total people that played on Saturday. Okay, and again, we gotta take that whole thing, put it into the calculator. So we need 28 divided by 174. Get that lovely decimal, but again, we're not done yet. That's not the percent. For the percent, you have to take it, multiply by 100. Okay, and again, we're gonna have to round to the nearest tenth. So look at that first number, it's a 0. So what's right after it? Right there. Okay, you see the 9. So think about it. Will a 9 make a 0 go up or stay? Okay. Hopefully you said go up. Okay, because it's a 9. Remember, it has to be 5 or bigger to go up, 4 or lower to stay. So we're going to round that to a whole 16.1%. Okay. All right, there we go. We got Saturday. Now we do Sunday. So again, exact same thing. Okay, do how many people won out of how many people played. Okay, and I don't know why they picked the same type of problem for all 3 examples, but that's what they picked. We're just going 3 out of 2. Ooh, I don't think those are going to be good odds here. 43 divided by 42. Yeah, it's not looking good. Again, that's not a percent. We have to multiply 100. Yep. And again, we are rounding. So we have a 7. Look for what's right after it. See that 6 right there. So will a 6 make the 7 go up or stay? Hopefully you said go up, because remember, I think I've said it like 4 times now. If it's a 5 or higher, it goes up. If it's a 4 or lower, it stays. So we want 17.8%. All right, last one. Again, the winners, 21 out of how many played, 416. 1 divided by 416. Again, that's not a percent. We need to multiply. Okay, and then we still have to round. Take that 0. That's right after it. Hopefully you see it's 6. Just like in the last one. Will a 6 make a 0 go up or stay? Hopefully you said go up. 17.1%. Okay. Now, does that answer my question about if 300 people played, how many would win? Did we figure that out? No, we did not. Okay. So, they were asking how many should we expect if 300 people played? Okay. Now, my suggestion is if they ask something like this, you're going to use the total. You're going to use this percentage to figure this out. Now, this is just like in your coin flip problem. You're going to take what your frequency or what your probability was, 71 over the 416, and you're going to multiply it, not by the 100 to get a percent. You're going to multiply it by the number of players we have. And that will tell you how many of them would have won. Okay, so do the fraction part first. So 71 divided by 416. You should get that big ugly decimal right. Now you're going to hit times 300. And that's how you find how many like outcomes it would have. if 300 people played, you should expect that many people would win. But again, you would round it to the 10th place, but because we're talking about like winners, okay, this is people. Think about it. Can we have decimals? Well, no, we cannot. You don't just see someone walking around with just like their arms flapping. Okay, you don't see that. Okay, you see a whole person. Yes, I know there are people with amputees that are missing limbs. I'm not talking about those people. Just like imagine Miss Howell's perfect math world where everybody is whole and we're all good. Whole people. Go with it. And if any of you, I swear, if any of you even bring up zombies, I'm not talking about zombies. We've had this discussion. Whole people. Whole people. Anyways. So, because it's 51.2, that 2 right there, that 2 is not enough to round it up to 50 people. So we're just going to leave it at 51 people. Okay? We're going to say, if 300 people played Joanne's game, only 51 of them would win using all of her probability. Okay? Now, ask yourself, would that number change if they told you that 300 people played on Saturday? You would have to use the Saturday probability, the 28 over 174. If it said Sunday, you would have to use the Sunday. But because it didn't specify the day, that's why we used it. Okay? So hopefully that makes a little bit of sense. It shouldn't be that much different than what we've been doing, but there you go. Okay? The only difference from what we've been doing is that this one tells you like how many people did the thing. In this case, it was how many people actually played the game and how many people played the game. Okay? It's not just our theory. Now, you don't have a paper like homework for this. You actually have homework on Prodigy. You have 2 assignments on Prodigy. Now, when you first open up Prodigy, I'm gonna let you know. You have some like elementary school lesson about how to round numbers because the number of people that could not round last week scared Miss. So we're taking it back. I want to make sure we all know how to round. So I want you to show me you know how. If need be, we'll take it a step further. We'll start adding round. Because again, I was concerned. Same thing with telling time. I don't know how many people or how many times I've gotten asked, what time is it? They're like, I don't know. So you have a Prodigy that's all about rounding and telling time. That's the first one. Second one is about probability. Okay, so just be aware. If it looks like you're getting the wrong questions, you're not. Okay, you're gonna have questions about time, rounding numbers, since a lot of us forgot, and then about probability. Okay, so make sure you work on those. Just so you're aware, it's about 80 questions. Okay, so my suggestion, you have about 2.5 weeks to do it. Do at least 10 questions every day. So if you do like 30 questions today, that means you're good for the next 3 days. Well, 2 days. Anyway, you know what I mean. But just keep that in mind. You need to do at least like 10 questions every single day, unless you just want to sit there and do it all in one. That's totally up to you. Okay, but it will count as 2 separate grades. So make sure you do them. 2 grades. So, all right. So, if you have any questions, I will be there at the end of the day today, or you can come see me tomorrow. If you need help on something, or I have 2. But this should be pretty easy. You guys should be okay, I think. Okay. Be nice, Mr. Fallon. If he writes any of your names down, you're in trouble. So make smart decisions. You know who you are. You know who I'm. All right. Have fun. Bye.